Hi, and welcome to DevSecOps 101 Best Practices. And if you notice, by the way, just really quick, it's actually DevSecOps. And personally, just so you know, I've actually removed the word DevOps from my vernacular, and I'm actually concentrating mostly solely on DevSecOps because I think it's actually everything we need to know about modern day DevSecOps practices, that everybody today should be doing it. And today we're going to discuss reasons why, and also too how the JFrog platform specifically around X-ray and our Artifactory product can provide you with an end-to-end DevSecOps solution with best practices around how to do everything from shift left to shift right. So who am I to talk about this? Well, my name is William Manning, or Bill. You can just call me Bill. I'm actually the Solution Engineering Manager for the Americas for our new business team. You can follow me on Twitter or also follow JFrog on Twitter. We have a lot of good information around there. Hopefully, if you're coming to this talk, you know who JFrog is. We're the Universal Binary Repository Management people. Our main product is Artifactory, and a lot of people confuse the term Artifactory as a verb that's out there, but Artifactory is actually our product. It's a way for you to do things like manage builds and manage also the third-party transit dependencies, which we'll dive in and talk about today. So first of all, let's start off and let's set the context for everything that we're going to discuss today. Number one, DevSecOps starts with software supply chain. Surprise, surprise, right? And today we're going to discuss some of the things around it and the reason why this has become such a phenomenon in the industry for a lot of good reasons. And there's a lot of reasons also too why you should enact these into your organization to provide the best level of support and the fully comprehensive ability to cover your company the way it needs to be covered. So this way it'll become one of those headlines that you read about. We're going to talk in a few minutes. But the thing is the headlines, right? We see these all the time. You know, we get alerts that suddenly there's all these flaws out there and third-party transitive dependencies, that, people's secrets are being leaked and user data and, some site's been brought down or we know the drill. But the thing is, though, is it's nothing new. This has been going on for a long time. This actually dates back even further than 2012. But the whole idea of what a supply chain attack is that your software is made up of other software and it's injecting these malicious components into that software, making your software susceptible. Now, the best part is you don't even know it's happening most of the time. But the thing too is that when we talk about software supply chain, we need to address one of the major features here. And we're going to discuss things like FOSS, right? Free and open source software. As the old adage goes, right? Free as in speech, not as in beer. But the thing is that over the years, these attacks have actually grown in intensity. And the thing is that there was one attack in particular on this third-party transitive dependency attack that caused the whole world to have an uproar. And you guys all know what it is because it's right there as the last item, but Solarwinds. And why was Solarwinds such a catalyst for the industry to really sit back and take stake in the way that actually software is being built? Like I said, this is nothing new. Even the X-ray product we talk about today is over 5 years old. But the thing is the reason why Solarwinds was such an attack was actually there was an elegant manner to it, to be honest. It was actually like a fourth level transitive dependency, meaning there was an implicit dependency that the developer who developed the software needed. And when he brought that in, it also brought in a whole series of other things. So the people at Solarwinds depended on dependencies, which depended on dependencies, you get the idea. Well, the thing is that fourth level in this somewhere was this one malicious package. And today we'll talk about how some of those things happen and why that's such a bad thing. But the thing is with that one that was so elegant is that it didn't even start until 14 days after the software itself started. 14 days later, chaos ensued. And the reason why it also garnered so much visibility was the 18,000 plus customers, but it wasn't just the sheer volume of customers. It was actually the specific customers, especially in the United States, that got affected, like the DoD, the Department of Homeland Security, the Federal Reserve Bank. A lot of the companies that depended on SolarWinds for their software needs suddenly found them, exposed. And this is like $100 billion global worldwide remediation that's been had to done since 2020. But the thing is that this is just one instance. And the thing is that, remember, the reason why this happens is that open source software comprises 85 to 90% of your code. Think about that, right? Most of your code is someone else's code. And the thing is that the reason why I always talk about it is that let's talk about the developer, right? I'm a developer by trade, obviously from the white beard that I have on my face. I've been doing this for a long time. And coders are artists. They're artisans in their crafts. They use palettes, and the palettes they use are these libraries that they need to complete the tasks that they do. They look at they need to concatenate a string, or, create a bitmap, or, create a hash table of different, fields and numbers. And, they look for ways to accomplish these tasks. And the thing is, as a developer, we have this blind naivety that we have about where these software components come from, because we really most of the time don't pay attention. All we know is that there's a library out there that will help me do my job faster. I'll utilize it. I'll utilize maybe one function out of 100, but what about those other 100 functions? We'll get to that later. But the whole idea is that, I use this function to accomplish my task. My agile sprint's done. I check off my KPI, my OKR, whatever. But the thing is that we have to take stock in understanding where these pieces and components come from, but how we can also not remove the velocity of a developer, or remove that innate ability for them to master craft something out of nothing, but utilizing a series of palettes. Like I said, they're artisans, they're like painters, and the paints they use are these libraries, and it makes up 85 to 90% of what you do. But why do these actual components, why are they so malicious in what they do, or how can these things happen, and how do we stop them? And that's what we'll talk about today, of all the different levels of approaches. So we got to remember, software is everywhere. And also, too, the amount of velocity has changed over time. I mean, if you've been doing, like I said, when I started coding, we would do quarterly releases. And then it shortened the cycles as Agile, and, from waterfall to Agile and other things. And then we automated more, CI/CD happened, GitOps, checking your code, have something automatically build so you don't have to worry about it and do its thing. The problem is that all these automated tasks, while they have helped tremendously, I'm not going to discount the fact that these have helped expedite the delivery of software, giving companies the advantage to produce feature sets and things, and that give them the edge above their competition, or help them go to market faster. But at the same time, we have introduced a susceptible risk to the software that we're producing ourselves. And the thing is that, remember, 85 to 90% is not built by your team. These are things that you're utilizing from random strangers on the internet, right? These are libraries that are out there. There's free and open source software. I am a huge believer in it. I'm a huge believer in the idea of giving back to the community and developing. I've been part of many open source projects over my lifespan. But the thing is that this erodes trust, these things that have been happening, right? How do you know how safe these are? It's like somebody walking down the street and they have an apple in their hand, and they take a bite and they go, "This is delicious." And they reach in their bag and they pull out another apple. Will you take it? Do you trust that person? Do you know this person? Just some random person, and the fact they pulled it out of their bag, right? Same kind of idea. But the thing is that when these attacks happen, we're going to go into the various methods in which these actual, people who do nefarious things with this, the thing is, in a lot of times there are some financial incentives. Don't get me wrong. But the thing is that, there are also non-ones. There's bragging rights and things like that. But we're going to dive into a couple of the mindsets behind this and the various types of approaches that, these hackers, for lack of better term, though that gets me into a whole other discussion, but that's not here. Really what this is. But the thing is that there's various approaches that are taken, and there are ways to combat this while still having the same velocity you have now, but also too addressing it so that the velocity also entails having security to protect not only your company in terms of reputation, but also financially. Because the thing is, and we're going to talk about this today, we actually introduced recently a portion of our product called operational risk. And the idea here is 74% of the binaries that you use to do your job are susceptible. They're either old, outdated, a bit abandoned. But the thing is, a big, large swath of those have fixes. So understanding that, if I just have a simple fix, that makes me that much more secure. Yes, in some cases, these are little baby steps that you're taking to ensure the safety and security of the software you produce. But at the same time, it's not hopeless. You have methods, you have ways to protect yourself. Because 99% of the software developed, 85 to 90% is full of open source components, right? 62% of all attacks have increased year over year, and they from 2015 to 2021. Now these numbers are pretty low actually in a way, because I have another number that's way more scary. But the thing is that it's increasing. It's going at velocity. And actually during the pandemic, when people had a lot of time on their hands, there was a huge increase. I'm talking a 650% increase in supply chain attacks last year alone. Think about that. That is massive. Think about the sheer magnitude of the things that are being introduced that could cause potential threats, problems, cost your company, lots of money, reputation. I mean, think about it. Suddenly all your information has been released because of something that could have been easily fixed. And suddenly, you have users leaving your site, or you have people saying, I don't want to use that because I don't trust it because of what I read in an article somewhere. You know what? It's very easy. It takes seconds to ruin a reputation. It takes a lifetime sometimes to garner back. Well, the thing is software supply chain hacks happen for a lot of different reasons. First of all, it really is low effort. The thing is that most of these attacks are pretty nominal, and they might expose one little particular detail, a field, or it might be a way for you to, connect to something. I mean, come on, look at Log4j. Log4j, this is something that was used for the longest time. There was actually info and warnings, by the way, going out before this saying, hey guys, we're investigating this mess. But the thing is that, think about this. You can interject a simple command line option and wipe out a remote disk because of a simple vulnerability in a library used in a piece of software. It doesn't take a lot of skill. It doesn't have to be elegant. These are hit and run kind of objects, right? If they get installed, they've hit it, and if it runs, it does something. It's easy. These attacks spread so rapidly, it's insane. Think about something like NPM, which I'm going to talk about a little bit later. I call it the house party as a joke. You invite 3 friends over and 500 show up, right? So 3 implicit libraries that you state in your package.json as a developer, and it brings like 500 friends because dependencies of dependencies of dependencies. You have implicit dependencies that you said, and then there's all the rest. But the thing is that these libraries and these various components that we're going to discuss today hide in plain sight. They're in these repositories. Once something is uploaded associated to another transitive dependency, it is dragged along with it, right? And the thing is that this has actually caused a widespread issue in most companies in the trust of these third-party libraries. But like I said, there's old methodologies. You'll hear this a lot. We have companies that come to us all the time. They're like, yeah, our security team wants us to submit a list of the binaries we need, the libraries, actually, I should say, that we need to do our job. They have to go through, pull them all in, approve them, and then, then they'll give them to us and we can use them. Think about how long that takes. Our methodology that we're going to show as part of this discussion will show you how you can still ensure that same level of security, but not have it stop velocity. But the thing is that it'll also help improve that relationship that your company has to feel safe in doing the jobs they do without the intervention of having to have your security teams harp on you or things like that, but still provide that level of security that can help your organization. But the other thing too is that they blend into the community. They're very stealthy. They just get in there, they do their job, they check their code in, they add it to, they pull down a library, they create their library, they make an indirect transitive dependencies that people just go, hey, it's 25 lines of code. It probably does something. I mean, come on, guys. Remember 2016 when the disgruntled developer for NPM got rid of leftpad. Does exactly what it says, but it was 11 lines of code. But when he got mad and removed his library out there and everybody tried to build it, it was like a 5th level transitive dependency that everybody used. And like 75% of the builds that used NPM failed, right? And we'll talk about the fact that these little pieces of code can cause massive amounts of damage. They can either open up, say, a back door or interject some malicious code that might do something more. I mean, the thing is that what happened with Solarwinds was that when it released, it was like a sniffer. Sniff around the network, tell me what you found, right? These are bad things, right? But the thing is, it's not hopeless. There are ways to fix this. So how do these attacks occur, right? So once again, let's talk about this in a visual format. I'm a developer. I have a project I'm working on. I've got to build a piece of software. I pick the technology. Let's say, NPM, Maven, Python. I don't care. Whatever stack works for me or works for my company or whatever the standard is that is around this, I pick the library. But the thing is that when I start coding, I realize I need libraries to accomplish the tasks I need, right? To do things, whether it's like a Spring Boot framework, or in NPM, I'm using something like React.js, like React, or, maybe I'm using Docker containers. I need a base level Docker container that contains a very specific set of runtime elements that I need to run my application. Whatever it is, it doesn't matter. Software is made of software. And I go ahead and I define the software that I'm using. And then I compile my code and it gets all happy. But what happens if one of those elements, maybe an indirect dependency, which is what everybody thinks in their mind, everybody goes, well, I'm not using any sort of malicious items. Well, you know what? Suddenly when you go ahead and you build your software, that's part of the product you're shipping. And when you send it to your customer, you've not only given them the software you need, but you've also given them so much, much more. But let's be honest. Most of these attacks do not happen at the implicit level itself. These attacks happen actually at the indirect dependency level, right? These are the ones that come associated with the binary I have implicitly stated as a developer. But it's still the same effect. They come in and then suddenly I'm giving my customers so much more than just my software. They're probably not going to be too happy. So let's talk about when software attacks, right? I always laugh when I show and I talk about this because it's really not the software. It's the people who created the software that created the package that's going to go and cause the damage. It's like somebody puts something in a package and ships it out, and that person somewhere else opens it, but it's anonymous. Where does it come from? I don't know, but it still can cause damage, right? Well, there's things like dependency and typo squatting, right? These are huge ones. I mean, there are people out there that will create malicious packages based on the fact instead of I before E, except after C, they do E before I. And suddenly you're fat fingering because you're typing, and you know what? You do an npm pull, you do a pip install, and you don't even realize it, and it still goes out and say that package exists with that dependency, and it spelled differently. You bring it in, you're none the wiser, because a lot of times actually with these, they'll actually fork the code. So you still get the implicit functions you're trying to get. So you still think you're in that happy zone of, I got the library I need to do the task I need to accomplish this in my sprint. But injected in there somewhere might be some other code that causes something terrible to happen. Let's talk about dependency confusion. All right, those are names everybody knows, right? And these names have trusted pieces that they do, right? I mean, look at Apple. They are probably one of the most, trusted names in security. I mean, I don't care what you think of them in terms of Apple, but when it comes to their security that they do for their users, it's pretty top notch. Look at Microsoft, Microsoft became one of the largest open source contributors out there. Unbelievable. Look at me. Like I said, I used to be the guy who'd be like, I can't believe they're doing this, and I'm an open source guy. And now I'm like, I like Microsoft. Surprising, I know. Or Netflix. They make some of the best tools out there. Look at Chaos Monkey, one of my favorite pieces of software ever created. If you're not familiar with Chaos Monkey, type in Netflix Chaos Monkey after this, not now, and take a look. It's amazing. The problem is that how do you know what libraries are real and which libraries are fake? Do you think that's the case? Look at PayPal, and that's the example we're going to use next. We actually did a test on this, and when we took a look, you look at these binary packages here, it says auth PayPal, or whatever that says, PayPal, and analytics PayPal. You're like, hey, PayPal is a trusted source out there. You know what? They're basically a bank. They must know what they're doing in terms of security. Want to know something funny? These aren't real. These are terrible packages that will go ahead and destroy everything that you're doing. These are fake. These are not real. You need to look for trusted solutions. And the JFrog platform, when we talk about it, I always said it's a DevSecOps platform. It's end-to-end security. If you're not familiar with our entire platform, I'm going to explain it to you right now on the 5-cent tour. So we'll start from left to right, or shift left to ship right. I know you hear these terms all the time. I'm throwing marketing buzzwords at you. Ready? But let's start off with the word Artifactory. It's this cornerstone of our technology. The best part about Artifactory is simple, is that when you look at Artifactory, it's a place to manage that 85 to 90% of the software you ingest to create your software. It manages those third-party transitive dependencies. It also manages the builds you create. So you can publish the builds, Docker images, NPM. We support over 30 package types. And the thing is we just introduced Terraform support, so infrastructure as code support, besides Chef and Ansible and Puppet that we already have. But also, too, we'll be introducing, I'll probably get in trouble for this, Swift support very soon to discuss things around iOS, macOS, tvOS, and all the other OSs that Apple does. But the thing is, it's also an SDLC enablement tool, software development lifecycle. So you can design it also as a way to monitor and maintain the build you produce, but also through their entire intrinsic cycle. You can have your repositories. We'll talk a little bit about this. We'll have dev and QA and staging and production. And we have a promotion API that allows you to promote it through the cycles. Then we have X-ray. X-ray is our security vulnerability license compliant and now operational risk assessment tool. It's a way for you to implement everything from shift right. You hear this, shift left. God, that was a mistake. But shift left at the developer level. So ensuring that your developers, the frontline defense for your organization, the place where the ROI on any security tool is greatest is at the developer level. And we'll show some of that. You can also interject it into your CI process and into your CD process too. In addition to that, you can have it automated behind the scenes. Everybody talks about CI for continuous integration, CD for continuous delivery. We also talk about CS for continuous security because our X-ray product is constantly in motion, constantly ensuring that you're safe and secure. Then we have distribution. This is our release management process. You can either use our distribution edges in our SaaS model to distribute things like SDK and software packages to your customers. You can also implement our immutable edge nodes. We have Artifactory edge nodes are lightweight immutable versions. You can use them in a hybrid model, either in the cloud, your ZC. But what they are is it's a way for you to distribute your software using a component called a release bundle, which allows you to securely digitally sign a group of binary packages you want to push to a location to these edges for retrieval. But also, too, the thing is that you have the ability to use our X-ray product to scan them one last time before they go out into the world. Then we have JFrog Connect. It's our IoT platform, right? This is an MDM, so it manages your devices, provides remote access, remote assessment, so you can see how they're doing, but also ways for you to distribute your software in real time. Do things like blue-green testing if you wanted to, right? This gets your software products to remote devices that are IoT-based. We have pipelines. This is our CI, CD, and CI orchestration tool. The idea here is simple. It's a fully scalable CI process, all built in Kubernetes, where the runtime can reflect the actual elements you might need to run your software. It could be Debian-based, CentOS-based, Windows-based. It's also built so you have templates. It's all YAML-based. There's no plugin, so it's all native integration-based. So you can even do things like running PowerShell or native Kubernetes commands. Then on top of that, you can use it as a way to package up your software through our distribution and distribute it out and also implement it. Because like I said, it even has Kubernetes connections in it. So you can actually even do Kubernetes runtime commands. You could also extend it as an orchestrator, keep your current CI processes in place. And when they finish, have a CI job done or a CD job done in pipelines, including things like approval processes or blue-green testing. On top of that, what also is nice, we have a thing called signed pipelines, which is a blockchain style ledger for all the stages of the actual build process that you do. And then lastly, we have Mission Control and Insight. Mission Control and Insight is a holistic view of how the whole system is operating. And Insight is a way for you to capture all the data that you have. And the data that you have, you can utilize in things like Splunk. I'll just show you a quick example here is actually, I have a thing that I'm doing here where I'm actually using this. Oh, right now I probably just picked a better time frame. Like I'll come back to this, but let's go ahead and let's look at the previous year. I'm going to submit this and let it do its job, but we'll come back and it'll actually show you that here we go. Here's all the data that I collected on assessing my vulnerabilities as an organization for 2021. This lets me know how many vulnerabilities, how many license issues, violations. So there's a tremendous amount of data we provide for you to make better decisions. So now that we've talked about that, let's go to the next phase, right? Let's talk about X-ray for a minute, right? It's automated security and compliance, and now also to operational risk assessment. So first of all, it allows you to scan all those components as you're bringing them in. It allows you to get full visibility. And one of the things we're going to talk about at the end today, the bonus round on this, we'll talk about software bill of materials. Everybody talks about it. And I'm going to show you how easy it is for you to get that. But it's a full visibility into your supply chain, not only where it's being used currently in the build you're assessing, but everywhere else, the blast radius, as I call it. What else has this affected in my organization? And how can I fix this? We're also going to say, fixing what matters fast, right? So the impact analysis component of this is not only that, but also the remediation aspect, right? So assessing the actual things you're doing, but also the remediation aspects are just as important. And this helps improve your security posture. And the best part about it is a majority of these things can be implemented pretty rapidly and also behind the scenes. And even if you implement Artifactory already, or you want to, once you've implemented Artifactory, you can do this behind the scenes without even the other teams knowing it, while still providing that same level of security that you need. And on top of that, it integrates everywhere, right? So the thing is, it's got our API, our CLI. I'm going to show you that today. You can implement it to your CI process, but behind the scenes, it's continuous. It's constantly scanning, and it works everywhere, right? This is another thing that we do. So let's get to the next part of this. When I look at this and I break all those individual pieces out, and all those pieces I talked about the platform, as you could see here stated, you could see that we have things like IDE integrations, which I'll show today. I'll show you our CLI tool and how you can utilize that. I'll show you how you can use Artifactory and X-ray together to ensure that security at every level. And lastly, how you can actually use it as part of our distribution process, and even down to our Connect for IoT devices. So let's get into it. Now that I've talked about it, you heard me speak about all these various aspects. Now I'm going to discuss with you a demo. So let's first of all go in and let's take a look at the things that you can do. I'm actually going to use two systems here, because one system I have is actually being self-hosted, and this one actually has a very cool thing I want to show you, and I want to show you towards the end of this about assessment and how you can go in and actually trace things through the entire life cycle of the stuff that they do. But I want to show you some other things. So I'm actually going to log into this other system that I have here, because actually this has one of the newest components in it. And I think that we need to discuss it because we haven't discussed it yet publicly. You guys are actually one of the first, which is pretty cool. So first of all, one of the things you need to understand is that there are other levels of security that you have. Of course, you have things like user identity and management. And we have the ability to provide you with all that level of security around there. When we talk about storing the binaries and using the binaries, I'm not going to go too deep into this because we have plenty of 101, basically Artifactory 101s out there if you need to understand. I'm going to go very ancillarily over the components that we're going to discuss here, which are the repositories where you store the binaries. Specifically, we're just going to talk about local, remote, and virtual. So local repositories are the binaries that matter to you, your builds, the things you produce. Remote repositories are those third-party trends and dependencies, the 85 to 90% of the stuff you consume to build the software that you release. And then virtual repositories is an encapsulation. It's a way for you to go in and have all these things done the right way. So first of all, number one, let's talk about local repositories. And when we talk about local repositories, one thing you need to keep in mind is that you go in first, you design your local repository, not only, first of all, based on the package type. So let's go look at something like Docker, right? I want to have this as a Docker registry. And there's lots of reasons why. So first of all, you need to understand that anytime you upload a binary into Artifactory, whether you do it through uploading it or publishing it, or you do it through a third-party request, everything gets pulled into Artifactory, torn apart, turned into a unique SHA-256, stored as that SHA-256. And when we store it, we actually go ahead and say there's 1,000 projects all using the same library. We go ahead and we store it once and we reference it 1,000 times in the metadata. This allows us also to track and trace where this binary is being used. But in addition to that, it also provides a level where you can go in, and if you look here, I've got 296 gigabytes of physically stored binaries in my file store, but 1.94 terabytes would be if I expanded it back, put all the duplicates back in. The reason why I bring this up is that when we are talking about this and we talk about how we design the repositories, is everything is done at the meta level. So when I say I was going to design this, and by the way, we have a naming convention document, I'm being very rough here. I might say, my project is called test, it's Docker, and I want to design my repositories to match my software development lifecycle. This is another way of ensuring security so that you can go ahead and have dev and QA and staging and production. You can change the ACLs through these too, where developers might have a little more free reign and the actual, say, QA team can only read and then publish the results in, because you're going to want to encourage your teams to publish more metadata in for everything you produce, so you have one single source of truth that when you look at it, you get a true assessment of this binary. But when I go in, I might say dev, I might say QA as my next stage, or I might say staging, and then eventually production. This also allows you to assess where are the things in the cycle. How many things went from dev to production? You can actually calculate this information to say, we had 100 builds in dev, 25 got assessed by QA, 3 got put into staging, and then 1 got released, right? You can find out this kind of velocity assessment. But also when you design these, you can go in and do things such as include patterns and exclude patterns to say you don't want to store specific things. Like you might want to say, I don't want to store, log files or something. Then at the bottom here, the piece that's most important is this: enable indexing in X-ray. Because the binaries are stored as metadata, this metadata is then passed to X-ray. So remember I said X-ray is continuously scanning. One of the advantages of this is because it's metadata, it doesn't need the physical binary. It just has the metadata assessment, so it's constantly looking based on the data that we provide to assess it too, which we'll talk about in a minute. Now that you've actually gone in, if we take a look here, I believe in this one I actually have a Docker repo. So repos, I do. So if you look towards the bottom here, I might have dev and production and some others. I think I only have a couple here. I could always go in and add some other ones like QA and staging. Then we have the remote repositories, those third-party transitive dependencies. I'm kind of going through this a little quickly because if you want bigger details, go look at some of our other stuff. But the idea here is simple. Is that what you do is once again, you go ahead, you pick your repository, you pick your repository type. Let's go with Docker again in this case. So I might say, Docker remote. I actually already have this created in here, but I'm just doing it again. It's going to yell at me that it already exists, right? I can go in there, I can use paid accounts, free accounts. There's multiple ways to authenticate. You can do include patterns and exclude patterns to say, I don't want any binaries by this name. You might have one where your team says, you know what, I don't want anything with the word blah, if I could type, ready? Blah in it. I don't know. I'm just using that as an example. So no package name blah will come in. But I also, once again, enable indexing in X-ray. This will allow you to go in and make sure you can write rules and actions to take to make sure that those third-party transitive dependencies, even base container images and the runtimes that are in them are protected. And then lastly, you're going to want to go ahead and design your virtual repository, right? I'm not going to go too deep into this either. You guys, if you used Artifactory long enough, you understand what this means. And if I go in here and I type in Docker, I'm sure I have a ton in here, but this allows you to go in, have a central entry point. This is a terrible name, by the way. But below it, I have production and dev, and I might have a remote repository. And by default, I'm going to build something and deploy it. So now I've got a little touch on repositories. Let's talk about X-ray and let's talk about what you can do with it and the various aspects in which you can protect yourself as a corporation while still retaining velocity, but also understanding more than you ever wanted to know about the things you produce. So first of all, let's take a look at something. So first of all, on one side, I've got a list of binaries that I wish to assess. And just so you know, by the way, our X-ray product also does on-demand scanning. It also does local disk scanning using the CLI, so you can still produce scan results without it being in Artifactory. This is something I need to demystify. There's a lot of companies out there that say we don't do this. We do, and there's plenty of information online to address this. But on the other side, I need to match this up against something. And the stuff I matched it up against is a thing called Zuck or Zook, depending on who you talk to. It's the X-ray Update Center. It's our massive database of vulnerability and compliance. And the idea here is that we have NVD and NIST sources. We have a relationship with RBS. We actually have a research team. Once again, we are going away with it. Companies saying that we don't. We do. We are a CNA. We are a certified number authority, right? We can produce CVEs. We're one of the few companies in the world that do this. And we algorithmically and manually curate this information to turn into something tangible. So on one side, binaries, other side, data that we want to assess it to. Now, what can I do? So we have policies and watches. Policies are the rules and the actions you take, and watches is how you implement them. First, let's go look at policies. So with policies, you give the policy a name, you give it a description, and up to a couple of weeks ago, I would say pick one of two flavors. You know what? We're Neapolitan now. So we have 3 flavors. We got vanilla, chocolate, and now we have strawberry. Maybe you're not a strawberry fan, but it's Neapolitan. We're going to go with that. Well, if you take a look, we have security, licensing, and operational risk. This is our new kid on the block here, and we'll discuss a little bit of that today. So under security, I would go create a series of rules, right? I got more than one rule in a policy. So I give the rule a name. Then I have my criteria that I want to assess it by. First of all, I have minimum severity, which is CVE. So you have low to critical. Always include all severities at some point. Info and warning provide you with a lot of information, especially if a binary is being assessed for a potential threat. Then we have things like CVSS score. You can do V2 or V3. So you set your slider for 4 to say 6.7. If you don't know what CVSS score is, go look it up. It's actually a fine granular approach to understanding a binary in terms of vulnerability assessment. Is it a network component? Is it a data component, right? There's a lot of information in there. Also, too, a new thing that we have is that you can actually say issues that do not have fixed versions are not generated until a fixed version is available. What this means is, in some cases, there is remediation available for these libraries. Some are like, don't even tell me about it until there's a fix available so I can address it. Well, now we talk about that as being the criteria you're assessing your binaries by. Let's talk about the actions you can take to make sure that you're secure. So first of all, it's going to generate a violation in Artifactory, and we'll show you what that looks like and how awesome the detail is. You can also do things like trigger a webhook. It actually is a simple JSON post. Post it out somewhere, use your parser, parse out the data that matters to you, place it in the system somewhere. When you apply your policies, one of the fields that is there is a parameter for email address. This will allow you to send an email to a group or individual. You can also say notify deployer. What this means is that anybody who deploys software into Artifactory can notifications if they've introduced something potentially threatening or nefarious. There's a separate email here. The separate email here is a good one. This one is, so you say you have red team that handles critical issues or 9.1 or higher in CVSS score. One of the cool features that we introduced over the past couple of months is Jira integration. Inside of you go ahead, connect to your Jira, you select the project you want inside the watch, but this will actually go ahead and create a Jira ticket. So what does that look like? Well, here's an example right here. This is actually in my Jira right now. Here's a security violation. Here's the X-ray information. Here's a link back to the binary that actually contains it. And then here's all the information that's behind it. Another thing that you can do as part of this, and these are the aggressive features, so you need to be cautious when you do this. First, we have block download. Now, block download is actually where binaries that are already inside of Artifactory, continuous security, always scanning, suddenly new information comes about that the thing you were using yesterday is not so fine. Look at Log4j. We've been using it for 5 years. And hey, look, suddenly it's the worst thing that's ever been known to man. We actually released a tool to help companies get past that. But the thing is this stops the consumption of these binaries from that moment forward until you have time to assess it and then rule whether or not you want to allow it or not, or if there's a fix for it, which we'll talk about, implement that fix. But let's talk about shift right. I mean, left, oh my God, I did it again. Since this is already recorded, take it, all right? Shift left. Well, let's talk about that. Now, number one, let's talk about the automated behind the scenes, right? You still want your developers to have creativity and you want them to be able to ingest binaries, but assess them before they do this, kind of like the manual team. Here's my list of binaries. Can you go out and get it and then do some scanning on it and let me know if it's safe? This will do it behind the scenes. Block unscanned artifacts, npm install blah. It goes through Artifactory, it proxies that request, it pulls in the blah library with its 7 million other transitive dependencies that come with it. It gets stored in Artifactory, it gets accessed by X-ray, and then if it passes your criteria that you've defined, whether it's licensing, security, or operational risk, it gets delivered to the developer. This way you protect it before they even get their hands on it. But that's just behind the scenes. This is, you could implement this right away once you've implemented Artifactory and X-ray. The next part of this, though, is let's go to the developer. Let's go where it matters most. How do you get the information to them? There's a couple of different ways. So first of all, what if you have what if you use Slack, right? You're a Slack organization. You have Slack for your messaging. We do, right? So just to let you know, we actually have a Slack application out there that you can install, put it into your environment and connect it. And then if you take a look here, you can see actually in my Slack, here's the JFrog actual Slack application. And if I go into my Slack alerts, you can see where the tool is actually publishing information based on the assessment of the things that I've done. And I have instant access. So as a developer, if I'm using Slack, this is one methodology I can use. But let's go even more to the point. Let's go right to the developer themselves. And one of the nice things that we also introduce here is we actually have plugins for IDEs. So whether it's IntelliJ, Eclipse, Visual Studio, or in this case, VS Code, my favorite editor, right? I was an Atom.io person. Now I use VS Code because it has all my favorite plugins. I don't have to go and do anything. But if you look here, we actually, in this NPM project, we're breaking down the actual binaries and if there's any potential threats. In this case, I've got a threat here. I call it binary shaming. Yes, that is elegant, isn't it? The idea here is that no developer wants to be the developer that checks in things with red or orange, right? Because you're introducing something potentially threatening. So we look at the component itself, you can see the version, its type, its scope. Are there any issues? And even its licensing. Well, you can see that it has a severity level of high, but it has remediation. So it actually has the ability, if you say, hey, I'm going to go from 3.04 to 3.05, this will alleviate my issue. I've addressed it where it matters most, whether it is the ROI is greatest. Further down your SDLC, the cost goes up exponentially. But let's also talk about people who don't use IDs. Let's talk about CLI tools. Well, if you're looking here inside of my, and this is my personal desktop here. And if you look, I'm actually using our JFrog CLI tool. I ran a JFrog CLI command called JF audit, and JF audit actually went ahead and actually composed a list of vulnerabilities based on my local desktop that I did here. I did an npm install. It actually looked at all the way those binaries are being utilized, how they're all together, both direct, implicit, and indirect transitive dependencies, and it lets me know, hey, by the way, I've got issues. Well, I know I've got issues, but in this case, the actual components I'm using have issues. What about Docker? All right, now here's the thing. A lot of us out there, and if you're not doing it, I recommend reading it. I'm a huge 12-factor application guy, right? I love the idea of it, getting rid of that whole works on my machine, right? So all my development I do personally, I have a Docker image that runs. It's the same Docker level OS that I'm using in my production. So I have my IDE, my local file store attached to it. So I always make sure. Well, how do you know that those are safe and secure? So first of all, I'm going to show you later on, I'm going to show you inside of Artifactory and why that's so meaningful. But what if your developers are pulling it down to their desktop? Well, we actually just introduced something really, really, really awesome. And what we've actually introduced is actually our Docker desktop. So this is actually my Docker desktop with our JFrog extension actually installed. And if you look here, I can pull down any Docker image to my desktop, and this will go ahead and connect it to your X-ray installation without this even being an X-ray, an Artifactory, by the way, because we are one of the most awesome container registries. But the best part here is I'm assessing it right here, right? I can actually tell if those are actually nefarious or not. So this is another level, IDE, CLI. I also have the ability to use now the Docker desktop. But let's go back to Artifactory, right? And I'm going to talk about build integration next. I think this is super important. So let's go back in here. Let's go back into my instance and let's talk about other things. So one of the other things I talked about was distribution, right? Packaging up those things like maybe Helm charts and Docker images and publishing them and deploying them with pipelines. Well, I can also make sure they're safe and secure by assessing them one last time. Then we have the, of course, fail build. Now, fail build is great because, right, it just sends an exit event, CLI, IDE, whatever, it doesn't matter. What it's doing is it's going in and saying, hey, I'm going to fail this build based on this action. But one of the problems is that what that is that a lot of the times it's forcing your developer by killing the build, and other developers are doing the same build and suddenly the same thing happens. And suddenly they're like, hey, Bob, you know what? You introduced something that broke all of our builds. Please fix it. Well, you can introduce also grace period. Now, grace period says, you know what, we're going to give you 3 days to fix it, and then we kill it completely. But this gives your developers a chance to take a breath back and say, okay, I know this is bad. You know what, let me go find something better, or let me see if there's some other remediation around it. Let's talk about licensing, right? Just as important. So in our rules for licensing, you give the rule a name. You give it a criteria, though, in this case, is different. But the actions are the same. We treat it just as severely. So of course, we have all 435 open source licenses on the market, right? These are the major ones. Other people say there's 2,600 and stuff like that. Those are actually mostly corporate licenses, okay? Let's be honest. These are the open source ones. These are the ones that if you're an open source developer, you go with, right? So we have the allowed licenses. We have the banned licenses. You can upload your own license and add it into this so you can assess that too so it doesn't get flagged. But what if it's not one of those licenses? What if it's unknown? You don't know what it is. You're going to want to find out why. Or why is there more than one license? Sometimes these are indicators that there's something potentially malicious going on here. Then we have the next stage of this, right? Operational risk. This is new. Not many people know we have this. This is a brand new entity that we're actually bringing in. And this is the longevity, the life cycle of a binary. Well, you know, the thing is that, remember I said 74% of the components you have either have one major vulnerability, they're old, outdated, abandoned. Well, we now have the ability to assess that. So you give it a rule. And then we have, by the way, on our website, we have assessment criteria. There's a metrics of information on how things get assessed in terms of operational risk. So if you want to see what those are, we have them below, right? Is this an end of life? Right? Is this, you know, we have also, by the way, operands here. So you can say and or, right? Is there, you know, what was the last, you know, really, you know, was it released in the past 6 months? You know, how many releases are greater than this, right? So I have my version 1.01. How many releases after this? Right? You know, it needs to be greater than 4. Okay, it means that somebody keeps maintaining it. You know, is there a cadence, right? Are they releasing every week or are they releasing every 5 years? How many commits have there been in this year, right? That's a good indicator too. Have they been fixing it? Also too, is there less committers, right? So maybe things go down, or in some cases, risk severity level, right? This comes back to the risk assessment. But once you've actually gone in and you've defined your rules and policies, now you're going to want to go in and implement them. And we implement them through a thing called a watch. And with a watch, you actually go in and give it a name, you give it a description. Here's that recipient list. Here's your JIRA profile. So once you've connected, you would actually go ahead and select the actual component that you want to look at. And then you say here, by the way, I'm going to go in and I'm going to use my license policies and maybe some security policies or whatever. Now I go in to assign those, and then I choose how I want to implement them. I can either assume at the project level. I didn't even go into projects. There's a whole talk on that. Projects is a way to provide more of an RBAC style implementation where you have super users that run the environment, and then you can have project admins that run their own projects. But you can say, I want all projects to have the same security. I want to do it by specific projects, or I even want to do it by patterns, so it's more blanket, and say, I'm going to assess everybody with the word dev in their name, right, for their project. Or I can do it by resources. I say, I want to do all repositories that I've flagged with indexing and X-ray. I want them all to have the same one. I can do specific ones. I might assess development differently than I do production. I can also do it by regular expression. And I can do the same thing for builds and the same thing for bundles. Now, let's go look at 2 things. And this will be the end. So first of all, let me address the elephant in the room. So first of all, just so you know, here's the on-demand scanning where you can actually see if you've actually scanned something locally or something that wasn't part of it, like a remote Git project or something. We also have reports, licensing, vulnerability, and all those kind of things. But I want to show you the important reason on why you would do these things. And in this case, I'm going to go extreme. So this will be the last part of the discussion. So let's go ahead and look at this. So first of all, build integration. I'm actually going to show you a Docker build in this case. And in my case, instead of using our pipeline product, I happen to be using Jenkins. So with Jenkins, I can actually go in here, and if you look, I actually can clone my GitHub project, pull my dependencies, build, test, deploy, scan it as part of the assessment, and use my promotion. I'm kind of zipping through this because, like I said, there's whole other talks based on this. But the important part is if I were to look at this DSL, you can see here where I actually have a stage where I'm actually going ahead and I'm going to scan this with X-ray. I just supplied the build name, the job number, and I say X-ray scan. And by the way, I'm not failing it in this case. But also too, I mean, if they've passed my unit test, and like, by the way, just so you know, I can actually send metadata to say it passed my test or failed it. Once again, queryable data that can be really important to you. By the way, you can also go in and query Artifactory to make sure you're installing the latest versions of applications. And the reason why I chose Docker is they're very black boxish, right? The thing with the black box mentality is that how long would it take you to like unravel a container to find out what's in it, right? Including what application layer is in there. So let's go in and take a look for a second. So as you can see, this was released, but this has a lot of critical issues. So number one, in this case, this is the important part. And from a remediation aspect, I had a person recently tell me that it used to take them anywhere from weeks, days and weeks to assess and cause root cause analysis. And we've knocked it down to minutes and hours. Let's take a look. So first of all, your standard instance would look like this, right? Where you have just a bunch of layers. They don't mean anything. If you use our approach, I wanted you to know that first of all, if you click in here and I look at say the dependencies, you can see here that I can see that here's my node front end and the Java backend I'm hosting in this container. I understand the application, the runtime, and I also understand the base OS. I know everything about this container. Then I can go in here, see what environment is there. But the other thing too, I should probably hop back for a second is, what if build number 91 is terrible? And say build number 81 or 80 was better, right? Better system. It seemed to operate better. How long would it take you to address that? Well, I can go in here and do a quick diff and say, hey, you know what? The node front end hasn't changed in a long time, but the Java backend has changed. I can show you any environmental system information. Hey, did somebody leave the debug flag on? Nope, nope, doesn't look like they did. I can show you all the X-ray data. Now, I'm going to let this load. Now, the thing is that the one we're looking at here is a terrible, terrible container. I have a goal of reaching 2,000 issues inside of this container, so it's taking a while to assess it. And we'll come back to that, but let's look at the security portion of this. You know, what level of information do you get? Well, let's go look at a popular item. Let's look at something like fast, right? So in this case, it's a spring work item, and let's go take a peek at it, right? If I were to go ahead and whoop, let's go back in, I hit my space bar by accident. But let's go in and take a look. Well, first of all, here's the issue. And this issue is actually pretty bad. It's really funny is this is a terrible CVE. Somebody got lazy and did a cut and paste. That's all they did. What I want to show you is that we actually see this as critical. Our security team said medium. Here's the reason. What if you have 1,000 functions in a library and one is bad, and you're using not even the one that's bad? Do you want to throw it out? Probably not. Well, our research team sat back and said, yeah, you know what? Depending on how you actually do this, it can impact you differently. But we've actually supplied you with a ton of information, and hey, you actually could just change the way this thing is out. The object is actually mapped, and you can fix it. We actually also include things like remediation information. You can upgrade it, you can patch it, you can change your deployment. And the funny part is we actually found this jar in a jar of a layer of an image of a build. That's how deep we went. On top of that, we also went in and we also provide reference materials on the patching and the advisory information. We have all the license components inside of here. See, it's multifaceted. I can also go in here and show you the best view possible. Remember we talked about, hey, these are those obfuscated layers. I know nothing about them. Well, I told you we tear everything apart. So I can actually go look at these and even see the contents of these layers. And if there's any issues with the OS in this case, these are the libraries in the OS. I can even go ahead and view them if I wanted to, or I can even assign a custom issue if I wanted to overwrite the fact that maybe it's a high assessment. I can also export this quickly for, say, violation and security reports for my security team. Or say your legal team is like, hey, we need to get all those license files. You can produce a license report. We talked about SBOM, software bill of materials. It's a composition analysis of everything that's used to build your software. With us, here you go, export SBOM, SPDX, and CycloneDX formats, both of them. This is becoming a thing, by the way, initially implemented by the government as a regulation, now bleeding into the private sector. But we also have all these other things like issues that you can get all your JIRA issues. You can actually do full diffs to see if things are different, like I showed you before, right? Has anything changed here? You can see here's the SDLC, but here's the thing. Now do this with anything else. Maybe this container has a bunch of vulnerabilities, like it does, but what if suddenly the node at front end, you question it? Well, let's go ahead. So I'm going from the Docker image in this case. This is root cause analysis. Ready? Here's the actual tar GZM hosting in there. Let's go back to this one, right? The tar GZM hosting in there. I have all the information on it, like what is it using for potential, any sort of dependencies. Here's its permissions, right? Here's its own X-ray information, right? I could show you, everything from security to licensing and whatnot. But the biggest thing here is that I'm skipping ahead a bit because I'm running out of time. But check this out. Well, I went from the Docker image to the application. Here's the build that produced it. But how long would it take you to find out where has this been used? Well, here's every build that has ever used, every Docker image that's ever used this node front end. I was able to address it like that. But I can go right from this build, I can go hop right from this one to the actual build that created it. So I can say, here's that tar GZM I'm hosting. Here's those 482 transit dependencies. Hello, house party. Right? And I can go in here and take a look and say, oh, maybe it's different from another build. So I have all that. But here's one for you too. What if you're reading an article and suddenly you find out that under, that Babel core, which you're using right here, is terrible. It's causing issues. It's leaking data. I don't even know anymore. Well, I can go in here, do a search for it, and I can say, well, you know what? We've actually used it in all these builds. How fast is that? Or what if suddenly, let's go in here. What if suddenly I go in here and I say, what about, I read an article and I want to find out. I read about the CVE 2021-44907. Well, I want to find out, are we affected by it? How long would that normally take? It would take a while. Let's do a search. Well, no packages, no builds, no artifacts and bundles. I got an answer like that and went through all the binaries here and said that none of them are actually part of that. But the last thing I want to show you before I end this discussion is also I want to go in here and I want to show you the latest thing that we have. And I think it's super important. And this is actually the idea here is that when we look at X-ray data, I showed you violation, I showed you security, but our new thing is here, operational risk. This is super, super important. This lets you know that the binaries that you're using, what is their life cycle? Like this binary I have right here hasn't been updated, since 2016. The current version is 201. The last version that was released was 204, and there's one commit. This is something important. And then I have one last thing to talk about, and I will bid you adieu. And the last thing is how do I also do this so that I implement it in something like GitHub or GitLab or even Bitbucket? Well, just to let you know, we also released a thing recently called Frogbot. Frogbot is free. You can go ahead and utilize it. And what this does is this connects to your instances. And every time you do a pull request, say you go ahead and you add this in, you actually add it in using GitHub Actions or in GitLab, there's a way to do it. And also Bitbucket will be very soon. But every time you do a pull request as a developer, you can actually go ahead and X-ray will go ahead and assess it. So this shows you that you have a lot of options in terms of security. You have a lot of ways that you can use the platform, a multitude of different vectors you can attack the same situation and figure out what works best for you. So saying that, I am actually going to bid you adieu. Thank you so much for today. I hope you appreciated the information. Go forth and protect your organization and protect the people that you have. Be safe, be wonderful, be well, everyone. Cheers.